All right, so now we're actually going to do a whole hypothesis test based off this when it comes to it. So the last section, right, you go into it and actually go to the nitty-gritty of the background information. So all this pretty much, these two sections are all about, because I put them together, is, for proportion and mean, is what is going to be our test stat, because that's the only thing we're actually missing when it comes to a complete hypothesis test, okay, when it comes to it. Okay. So when it comes to it, so we talked about how to find the null alternative hypothesis, which is step 1, how to write the conclusion, which is your final step, step 3. So now we're going to analyze it, so which is what step 2 is all about, right? So we talked about analyzing it. Now the question is, how do we find the test stat? That's what we're going to be dealing with in this section here. Okay. So the last part is, again, really finding the test stat itself, and then there's two different ways depending on which we're doing, proportion or mean. So for hypothesis for proportion, our test set is going to look like this. So it's a z-score, right? Because we're doing z-scores when it comes to it. It is p hat minus p divided by the square root of p times q divided by n. And here I tell you guys what each represents, right? So p hat is the sample proportion, p is the population proportion, q is 1 minus p, and n is the sample size itself. Okay. Now for mean, it's a little easier to deal with, which is kind of nicer. It's a t-value again, right? Because we're doing mean t distributions. So it's a t equals to, notice you've already done this before. This is the central limit theorem, right? It's x bar minus, so the sample mean minus mu, the population mean, divided by s divided by the square root of n. So s is sample size, and s is the standard deviation, and is sample size, right? With degrees of freedom of n minus 1. Okay. So, this is something you've seen already, right? So we're just talking about again. This could be a little tricky when it comes to it. Okay. So here we do an example of how this actually flows out. So I'll read the example. So in a survey, 1,884 out of 2,246 randomly selected adults in the United States said that texting while driving should be illegal. Consider a hypothesis test that uses a 0.05 significance level to test the claim that more than 80% of adults believe that texting while driving should be illegal. All right, so remember, the first thing you want to do is find the null and alternative hypothesis. So remember, the null alternative hypothesis literally goes from the claim, right? What are we asked to do? Here's our claim. So we have more than 80%. So since we're doing proportion, right, because it's a good percentage, we have P is equal to 80%, so 0.8. And alternative is more than means greater than, so P is greater than 0.8, right? So that's step 1, literally just find a null alternative. That's it, right? That's what we did in the last section when it comes to it, okay? So now step 2 is doing this part here, or partially this part. So finding our test stat. And since we're doing proportion, we're going to be using this equation to find our z-score. So here we need 4 numbers. So when it comes to it, our sample proportion is what's given to the question, right? So in other words, according to our sample, what's the proportion of believe texting while driving should be illegal? Well, they told us, right? How many out of how many here? So we just divide that, and it gives us roughly 0.803. So that is our p hat. Okay. So now q is 1 minus p, right? So 1 minus 0.8 is 0.2. And then finally plug everything into our equation here. Okay. So again, knowing that P is 0.8, because we literally just wrote that down, right? So we know that's P. Q is going to be 0.20. P hat, found in using our portion, is going to be 0.803. And our sample size N is going to be 2,246, right? Literally just going off the information given to us here. Okay. So using these 4 numbers, we plug in respectively where they're supposed to be, right, in the exact same template. So remember, the key thing is p hat minus p, right? Now, if you're not sure what p is, you literally should write this down in step 1, right? That's the point of step 1, is finding p. It tells you right there, right? You wrote that down when it comes to it. P hat is the sample proportion, right? Hence why it's called the sample proportion of it itself, okay? And now you just slowly break this down, and we should get a z-score of 0.36. Okay. Now remember, the last step is to analyze it, right? So once proportion, still in step 2, is analyzing it. So when it comes to analyzing it, we need to find our critical value. So since our alpha is 0.05, right, and we have a right tail test because it's pointing to the right. So no, we have a right tail test. So again, remember this one. To find if it's right tail test, we go over here. So significance level of 0.05. We have a right tail test, so our critical value is 1.645. So that's our critical value here. Right? So this is what we should be shading. All of this. And now since our test stat, so I'll just write here, so our test stat was 0.36, right? Well, 0.36 is somewhere around here, right? It's roughly there. So here's a question. Is our test stat within the range? In other words, is it within the shaded region I just shaded? And hopefully you say no, right? Because it's not in there. So therefore, again, going back to our conclusion, right? That means we do not reject our null hypothesis because it's not in the critical range. Okay? So notice all this comes into play now into this case. Okay? So last step, right? We do not reject our null hypothesis. So now we go on to step 3 is how we write our conclusion, right? And that's going back using, again, our portions, right? And just other words, literally just using, following the flow chart. So in this case, the first step is, does the original claim have equality? And no, it does not, right? It says more than. More than does not say equality. So we say no. Next step, do we reject or do not reject? In this case, we do not reject, so fail to reject. So we should be in box 4. So I'm literally going to write, there is not sufficient sample evidence to support the claim that, and notice that is exactly what I wrote down. Right? There is not sufficient sample evidence to support the claim that, and now we go back, what was the actual claim? So literally after the word claim, you copy everything down. Claim more than 80% of adults believe that texting while driving should be illegal. And notice that's exactly what you should write down. And there is your conclusion. Okay. So it's a lot of stuff put in together. So all of this, the only new stuff in these 2 sections is literally these 2 equations. That's pretty much the math behind the hypothesis test, because everything else is pretty much removing a lot of writing down based off that information. Okay, so let's actually try one out fully on our own here. Okay, so question 1 says 56 out of 104 pregnant women correctly guessed the sex of their babies. Using this sample to test the claim that the success rate of such guessing is no different from the 50% success rate expected with random chance guessing. Use a 0.05 significance level. Okay, here's the question. Are we doing a hypothesis for proportion or mean? So hopefully say proportion, right? Because we're given percentage. All right, so step 1, we got to find our null and alternative hypothesis. Okay. So our null hypothesis has equality, so we're assuming it's still 50%, right? So 0.5. Okay. Alternative is, well, what do we ask? So different from. So no different means not equal to. So I don't know if it's more or less, but it's different than, right? So it's not equal to 0.5. Right? So that's step 1, right? Find null alternative hypothesis. So now step 2, we want to find our test stat. And since we're doing proportion, we know it's going to be a z-score. And we're going to use the same equation as the example above. So we need a couple numbers to write down. We need p hat, p, q, and n before we go any further. Okay. So one number you should go automatically is p, right? Because you should have write that down already. So that's going to be 0.5. So q is 1 minus p, so that's also 0.5. Okay. Sample size in this case is 104. Okay. And then lastly, we divide, to get a p hat, we divide 57 divided by 104, which should give us approximately 0.55. There's your p hat. And now we plug it into our equation. Okay. So we know, according to our equation, it is p hat minus p. Okay, so p hat minus p. So 0.55 minus 0.50 divided by the square root of all inside 0.5 times 0.5, that's p cubed, divided by n, which is 104. Okay. So we slowly break this down. You should get a z-score of 0.98. All right, so now we go into the portion, right? So now we go into the analysis portion. So what type of test do we have? Well, let's figure out. Since it's not equal to, we have a two-tailed test. I'm going to shade both ends of this tail. Okay. Our alpha is 0.05 from the question. So if we go back to our formula sheet, so alpha being 0.05, and we have a two-tailed test. So we have two critical values, positive 1.96 and minus 1.96. Okay. All right, and then finally, we plot our point. So our z-score is 0.98, so it's roughly somewhere over here, right? Those are the exact. Okay. So here's the question. Is our z-score in the shaded regions? Again, hopefully you say no. So therefore, we do not reject our null hypothesis. So now finally, the last thing to do is to write our conclusion down. So step 3, our conclusion. So that again goes back to our portion, and we just follow the flowchart. Okay. So first thing is have equality. So here you go. What does no different mean? So if I say I am no different from you, that means we are the same, correct? Well, the same means we are equal to each other. So this time it does have equality, right? No different means we're the same. So you would say yes, it has equality. Next step, do we reject or do not reject? We said we do not reject. So we're in box 3, or go down, so no. So we're in box 2. So we would write for our conclusion, there is not sufficient evidence to warrant rejection of the claim that, okay, so now over here, and now what was the claim? So I'm going to go up here. So the claim is, so here's the word claim, that the success rate of such guessing is no different from the 50% success rate. And there we go. So this is a complete hypothesis test. A lot of information to do, right, when it comes to it. So pretty lengthy tests. Okay. And there we go.